Alright, this is the derivatives test part 1 solutions. The first question we see its definition of the derivative. So we have to remember that's the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And we have f of x right here. I like to just write out f of x plus h is equal to 2. Anywhere I see an x, I'm just going to replace that with x plus h. And then, so now we just substitute, so we're going to have the limit as h approaches 0 of 2 x plus h squared plus 3 minus, now be careful here and put this entire thing in parentheses because we're subtracting everything, all divided by h. Then we have to, again, we always have to rewrite the limit until you actually plug in 0 for h. So we're going to expand this. That's going to be 2x squared plus 4xh plus 2h squared plus 3. I'll distribute this negative, minus 2x squared minus 3, all divided by h. And I did do 2 steps here. I FOILed out x plus h squared, and then I multiplied everything by 2. Okay, next we can just kind of cancel out our like terms and see what like terms we have. So the 2x squared and the negative 2x squared and the plus 3 and the minus 3 can all cancel out. And then from there we'll rewrite this is the limit as h approaches 0 of 4xh plus 2h squared all divided by h. And you can factor out an h there. So we have that's equal to the limit as h approaches 0 of h times 4x plus 2h over h. And then we can divide out the h. And now we don't have a 0 over 0 because before we always had, dividing by 0. So now we have the limit as h approaches 0 of 4x plus 2h. And when we substitute in 0 into h, that gives us 4x plus 2 times 0, or just 4x. So that's our answer for number 1, and using the formal definition of the derivative. Okay, question 2 asked us to just find the derivatives and then plug in, find the derivative at a certain point. So part A is just power rule, so we get g prime of x equals 12x cubed minus 6, and then the 8 will just go to 0 when we do the derivative. So that's the first part of the answer. And then the second part is we're going to find it at this point. That's x, that's our y, or 2 would actually be, in this case, g of x. And, or really it's g of 1. Anyways, so we're going to plug in anywhere we see an x, we plug in 1. If there was a y, which there's not, we'd plug in 2. So g prime of 1 is equal to 12 times 1 cubed minus 6, which is just 12 minus 6, which is just 6. Okay, part B, 2b. First we're going to find y prime. The 4 is a coefficient, we just leave it, times the derivative of cosine is negative sine of x. Make sure you know that this is multiplying, so we can rewrite this as negative 4 sine x. Then y prime of 3 pi over 2. We need to remember our trig, and that when you plug in 3 pi over 2 for sine, okay, it's sine of 3 pi over 2 is negative 1. So that's equal to negative 4 times negative 1, or just positive 4. Alright, question 3. asked us to find the fourth derivative. So again, if we notice that we have a chain rule, I really want everyone to be doing the AB method right now. So the inside term here would be our A, so we're going to say A is 2x plus 1, B is equal to 2, or sorry, sine of A. And then A prime would equal 2, B prime would equal cosine of A, which is equal to cosine of 2x plus 1, right? A is 2x plus 1. So we multiply those together, and so we get f prime of x will equal 2 times cosine of 2x plus 1. Okay, now we need a fourth derivative, so that's our first derivative. Okay, my inside term is A is 2x plus 1. B is going to be 2 cosine of A, which makes A prime equal to 2, and B prime equal to, derivative of cosine is negative sine, so this will be negative 2 sine of A, which is equal to negative 2 sine of 2x plus 1. So we multiply those together, and we get the second derivative of x, f, is equal to 2 times negative 2 is negative 4 sine of 2x plus 1. Now we do our a, b again. So now we're going to have a is equal to 2x plus 1, b is equal to negative 4 sine of a. That makes a prime equal to 2, and b prime, the derivative of sine is cosine. The negative 4 will stay the same, so it's negative 4 cosine of a, which is equal to negative 4 cosine of 2x plus 1. So that gives us, I'm going to rewrite it over here, that the third derivative, triple prime of x, will be equal to 2 times negative 4 is negative 8 cosine of 2x plus 1. Then we make our a the inside, 2x plus 1. Make your b negative 8 cosine of a. That makes a prime 2. B prime, the derivative of cosine is negative sine. Negative 8 times negative sine will be positive 8 sine of a, which is 8 sine of 2x plus 1. Multiply those and we get the fourth derivative of x is equal to 8 sine of, 8 times 2, 16 sine of 2x plus 1. Now that would be a lot faster if we didn't do the AB method, but for most of you guys I really recommend staying with this AB method because it'll really help you to stay a lot more organized, and that's what I want to see on your retakes. Alright, question 4. We see 3 secant of x times tangent of x, right? We're multiplying. Anytime you see more than one x, generally you can think that it's probably going to be product or quotient rule unless you're adding and subtracting. So in this case, this will be my first term times my second term. If you look at the notation, that's like f and g. So y prime product rule is we take the derivative of the first, which will be 3 secant. Derivative of secant is secant x times tangent x. So that's the derivative of this part, and then we leave times tangent x. Then you add on. Now we leave the first part alone. So we have 3 secant of x. We just left that alone. And then times the derivative of tangent is secant squared of x. And then if you want to simplify this, you can simplify this, and we can get 3 secant x tangent squared of x plus 3 secant cubed of x. And if you wanted to factor out a 3 secant of x, you can, but I'll leave this as our answer. Okay, part B is now quotient rule. So remember, low d high minus high d low all over low squared. So we're going to start off low times the derivative of the top. Make sure you put this in parentheses because we're multiplying by the entire derivative of the top. The derivative of 2x cubed is 6x squared, plus derivative of 4x squared is 8x, minus the derivative of 6x is 6, minus high d low, leave the top alone, 2x cubed, plus 4x squared, minus 6x, times the derivative of the bottom is 2x plus 3. If you want to put this all in a big bracket, because you know we're subtracting all of it, that's a good thing to do. All divided by x squared plus 3x all squared. If you left this as your answer, I would give you full credit. If you were going to simplify it, you could, expand and, certain things would cancel. But this would be full credit right here. But if you want to actually try to simplify this and you actually do keep simplifying it, you'll actually see that that you can actually simplify it pretty much all the way to f prime of x equals 2. So if you want to try that on your own and see if you can simplify that, that's good practice. Alright, question 5. These are both chain rule. You can see that we're doing an operation where the very inside is not just x, or the square root is not just of x. Okay, so we can rewrite this one as cotangent of 2x all to the 5th power. If you do the AB method, we'll get A is 2x, B, that's our A, is cotangent of B, and then C will be, this entire thing is our B, so C will be B to the 5th power. That gives us A prime derivative of 2x is 2, B prime derivative of cotangent is negative cosecant squared of A, and then C prime b to the 5th, our derivative will be 5b to the 4th. This becomes negative cosecant squared of 2x, and 5b to the 4th will be 5 cotangent to the 4th power of 2x. Okay, now we can multiply these together. I'm going to start with the coefficients. Negative 2 times negative times 5. So g prime will be, of x will be negative 10 cosecant squared of 2x times cotangent to the 4th power of 2x. And that's our answer. Okay, on part B, if we rewrite this, we'll get f of x equals radical secant of 5x squared. And you can do the AB method, I'll do that, but like I showed you guys in class, a much quicker thing that you could notice, anytime you have a squared and a square root, they cancel out. So that would make this problem a lot faster. If you didn't see that, then our very inside A is 5x, B is equal to secant of A, C is equal to B squared, and D is equal to the square root of C. That gives us A prime is 5, B prime is derivative of secant of A is secant A times tangent of A, which is equal to secant of 5x times tangent of 5x. And then C prime will be 2b, which will be 2 secant of A, which is 5x. And then D prime will be equal to 1 over 2 radical C, which will be equal to 1 over 2 radical secant squared of 5x. Okay, now we multiply these all together, and so we'll get f prime of x equals 5 times 2 is 10, and then we have 2 secant, so we'll get secant squared of 5x tangent of 5x, all divided by 2 radical secant squared of 5x. You can simplify that 10 divided by 2 is 5. And this is the answer most people who got it right put. Like I said, if you can cancel out the square root and the squared and simplify this a little bit further. And if you really simplify it, you'll get 5 secant of 5x times tangent of 5x. Alright, question 6. Find the slope. This is implicit. When we have x and y, it's implicit. So derivative of y cubed is 3y squared dy dx minus derivative of 4x is 4 equals 8 dy dx. Now we solve for dy dx, so I'm going to subtract and add. So 3y squared dy dx minus 8 dy dx equals 4. Factor out a dy dx. And then we're going to divide, so we get dy dx equals 4 divided by 3y squared minus 8. And then you plug in, anywhere you see an x, we would plug in 2. Anywhere we see a y, we plug in 1. So when you plug in 1 here, it's 3 times 1 squared is 3. 3 minus 8 is negative 5. So it's negative 4 fifths. And that's our slope. Right? Slope is our derivative. We have to remember that. Okay, next question. We have, this is important that it says it's the graph of the derivative. So all of these y values, they're not our f of x, they're our f prime of x. They're already the slope. So that's important to know. So if we look here, it means that the slope of the graph at x equals 2, its slope is equal to 1. So this y-axis is our slope. Okay, so this asks us to find a tangent line. So that's y minus y1 equals m times x minus x1. We have x1, we have y1, we need the slope. Well, this graph is telling me the slope. So I go to our x value, which is 1. Right, so I look at 1. And that point is 1 comma 3. This is the f prime, right? And 1 negative 2 is the f. So this is telling me that at x equals 1, the slope is 3. So that's my m. So we get y minus negative 2 equals my slope, we said, is 3 times x minus 1. You can change that to plus, and there's our equation. Alright, question 8 tells us this is continuous and differentiable. If it's continuous, we can set those two equal to each other at x equals 1/2. So we're going to plug in 1/2, and we get a times 1/2 squared is 1/4 minus c equals 8 times 1/2 plus 4. That's 1/4 a minus c equals 8. Then we also have, from the differentiable part, that means we can take the derivative of both of these. So the derivative would be 2ax, and the derivative here, right, minus c, that's a constant. When you take the derivative, it just goes to 0. And then the derivative here is 8x. So we say, when we plug in 1/2, 2a times 1/2 equals 8 times 1/2. That gives us a equals 4. So now we know a, and we can come over here, plug that in. 1/4 times 4 minus c equals 8. That's 1 minus c equals 8. And subtract 1, divide by negative, we get c equals negative 7. I do think I did grade this question incorrectly on the test. So if I graded yours incorrectly, just let me know. Alright, question 9 says write the equation of a horizontal tangent line. When we see horizontal tangent, we know that the slope is equal to 0. So we're going to take this derivative, y prime equals 6x minus 12, and set that equal to 0. Solve for x, we get x equals 2. So now we know the slope, we know x1, and to find y1 we plug x back into the original. So y equals 3 times 2 squared minus 12 times 2 plus 4, and we get y equals negative 8. So y minus y1 equals m times x minus x1. 0 times anything goes to 0. That's y plus 8 equals 0, or y equals negative 8. Alright, question 10. It gave us n prime of 3, so I know I want to first figure out what n prime of x would equal. And this g of f of x, that's chain rule. So that's my a. So basically, we could say a is equal to f of x. B would then be g of a, which means a prime is f prime of x. B prime is equal to g prime of a, which is g prime of f of x. We multiply those together, and we get n prime will be g prime of f of x times f prime of x. Okay. Then the second piece of information it gave us was this p prime of 3. So I also know I'm going to need to find p prime of x, which is quotient rule low, f of x d high, g prime of x, minus high, g of x d low, f prime of x, over low squared f of x squared. Okay, and now I can just plug these in. So n prime of 3 is equal to negative 4. So I'll say negative 4 equals, okay, now we're going to basically say that's equal to g prime of f of 3 times f prime of 3. So f of 3, we go to our table, it's equal to 3. So it says negative 4 equals g of 3 times f prime of 3 is 2. Divide by 2, we get negative 2 equals g prime of 3. Forgot to put the prime there. So that's our first answer. Then we can come over here to p prime of 3, that's negative 2, equals, okay, f of 3 is 3 times g prime of 3, we just found out was negative 2, minus g of 3, we don't know, times f prime of 3 is 3, divided by f of 3, f prime of 3 was 2, not 3. All divided by 3 squared. That gives me negative 2 equals negative 6 minus 2g of 3 divided by 9. Multiply both sides by 9. We get negative 18 equals negative 6 minus 2g of 3. Add 6 to both sides, negative 12 equals negative 2 g of 3. Divide by negative 2 and we get 6 equals g of 3. And again, this is another question I might have messed up on my answer key. We are doing a retake, but if you did get 6 here, I may not have given you credit. Alright, next question we have is let f and g be differentiable functions. And so it says g of f prime of x. So if we look at this is chain rule. So a is equal to f of x, b is equal to g of a. That gives me a prime is equal to f prime of x, and b prime is g prime of a, which is g prime of f of x. So that means that h prime of x will equal g prime of f of x times f prime of x. Alright, so h prime of 1 would equal g prime of f of 1 times f prime of 1. We have to do this inside part first. So that's g prime of f of 1 is 2. times f prime of 1 is negative 3. Then we do g prime at 2 is negative 4 times 3, negative 3, which will give us positive 12. Alright, question 2 says, if f is a function such that the limit as x approaches 3 of f of x minus f of 3 divided by x minus 3, we have to recognize that this is my definition of the derivative. So this is like basically saying f prime of 3. That's the definition for the derivative of x at 3. So it's basically saying f prime of 3 is dne. And if you recognize that, then the answer is pretty obvious, just the derivative of f at x equals 3 does not exist. Okay, question 3, we want to take the derivative. We see it's implicit, so it's 6x plus, right here that's going to be product rule. So we do the derivative of 2x is 2, leave the second part y alone, plus now we leave 2x, the derivative of y is just times 1 dy dx, and then it's plus y squared, so plus 2y dy dx equals 0. Okay, we'll subtract negative 6 plus 2y, so we get 2x dy dx plus 2y dy dx equals negative 6x plus 2y, sorry, minus 2y. Then I'm going to just divide everything by 2. So we get x dy dx plus y dy dx equals negative 3x minus 2y. Then you factor out a dy dx. You get x plus y equals negative 3x. Sorry, I didn't divide that one by 2, so minus y divided by x plus y, right, because I'm a step ahead of myself. So now we divide by both sides by x plus y, and we get dy dx equals negative 3x minus y divided by x plus y. Okay, now we plug in x equals 1. We don't have y. So we get y by plugging that, x equals 1, back into the original. That's 3 times 1 squared plus 2 times 1 times y plus y squared equals 2. When you have a y squared and a y, you have to set it equal to 0. So basically now we're going to solve and get y squared plus 2y plus 1 equals 0. We subtract 2 from both sides. Then you can make this y plus 1 squared equals 0. So we get y equals negative 1. So now I know x is 1, y is negative 1. So I plug those into my derivative. That's negative 3 times 1 minus negative 1 divided by 1 plus negative 1. That gives me negative 2 divided by 0. Anything divided by 0 is dne. Okay, question 4. And that gives us 1 minus 2 cubed minus 6 times 1 minus 2 squared, because we're plugging in x as 1, which is equal to negative 1 cubed is negative 1, minus this negative 1 squared will become positive 1, so minus 6, which is negative 7. So this is telling me that my slope is negative 7. You can do y minus y1 equals m times x minus x1 and then simplify it. But if I know my slope is negative 7, only one of these equations has a slope of negative 7. Right? These are all in y equals mx plus b form. Okay, so question 9, we look at it, and we're basically seeing the words continuous, differentiable. So we have to check, is this continuous? And I actually said at x equals 3. So this is actually a question where if it really truly were x equals 3, then we would only need to check this part right here, and because that's where, see how x is greater than or equal to 2, so at 3 it would be this case, and 3x minus 2 is both continuous and differentiable. That should have been the answer. The way that I think most people looked at this and the way I thought I was going to write it was having this be x equals 2. But in the future, like if an AP test did do that, then it would just be there and it would be both. Let's just pretend for right now if it did say at x equals 2, then that's where this is the piecewise, so that's where this is from the left side, that's from the right side. So to check continuous, then you basically say, is x squared, the original, is it equal to 3x minus 2? So you plug in 2, and you get 2 squared is 4. Does that equal to 3 times 2 is 6, minus 2 is equal to 4. Then to check if it's differentiable, you would take the derivative and you'd have 2x. Does that equal 3? Because we took the derivative of both of those. 2 times 2 is 4, which is not equal to 3, so it's not differentiable. So that answer would have been continuous but not differentiable. So technically I can give people a point back on 9 since I just wrote it incorrectly. That shouldn't have said x equals 3, it should have said x equals 2. Alright, then the last question is asking us which one of these could be the derivative. So we have to know that that's where our derivative is equal to 0. Then on the left side, our derivative is increasing, which means that f prime is greater than 0. On the right side, f prime is decreasing, which means f prime is less than 0. Actually, f is increasing and f is decreasing. So when our graph is increasing, the derivative is greater than 0. When the graph is decreasing, the derivative is less than 0. So basically we have to check every single one of these does have a 0 at 0. But if you look at this graph, that's the only critical point. That's the only time that the derivative is equal to 0. So if we see how this part B has extra zeros, we can cross that out. Part C has extra zeros, we can cross that out. And part D has extra zeros, so we can cross that out. So their only two options are A and C. On the left side it's increasing, so our derivative should be positive. This is negative. This one is positive. And on the right side it's decreasing, that's negative. So our answer is C. Alright, this was a long video. If you watched it all, good job. Go back, look at, maybe take the test again, look at the problems that gave you trouble, and ask me questions before Friday. The retake will be on Friday.